Hi everyone, it's Mrs. Summer here to talk about lesson 610, Stoichiometry Day 1. The goal for this lesson is to convert grams of a substance to moles of a different substance using the balanced chemical equation. So at this point, you should be able to start anywhere on this map here and get to anywhere else on the map using conversions that you know. So stoichiometry, remember, is using conversion factors to answer a question. In chemistry, we use it as the relationship between the amounts of substances in a chemical reaction. Remember back to the cookies example in the mole-to-mole ratios. We can start with an amount of one substance to get the amount needed of another substance, like eggs to batches of cookies. So, real-world example of stoichiometry. Back in quarter one, we all watched this video about how airbags work. So, when a car accident happens, airbags are filled with gas from a chemical reaction. Using stoichiometry, the manufacturer can calculate how much of the sodium azide needs to be stored in the car to produce just the right amount of N2 gas to save the lives of people in the car. Too little, airbag doesn't inflate as much. Too much, it could pop the airbag before it stops you from hitting your dashboard. So in this, we'll need to use more than one step. So we're going to use more than one tracks on our railroad. By doing this way, instead of in separate steps, it can ensure as much accuracy as possible. Now, that being said, if you want to do it step by step, that is totally fine. That's honestly how I do it for all of my other work. But the caveat being, you have to keep every digit until the end of all of your different steps. So you have to keep all of those numbers that you get on your calculator all the way through and then round at the very end. So here we're going to be our given, and then given units, the step 1 units. And then step 1 units on the bottom, step 2, and then where are you trying to go units. This is why we keep telling you to make sure you're writing down the identity of the substance you're using, even in those one-step problems when it's the same substance, because here's where you're going from substance of one to substance of another, and you got to keep track of those. So here's something that you are familiar with. How many inches are in 3 kilometers? So you would set up that problem like this. So your 3 kilometers, and then your kilometers on the bottom, because you want to cancel those, is 1 mile. 1 mile to 1 mile. Those cancel, feet and feet cancel, so the remaining unit is inches. And you would get the answer, and when you do all the math, you get 100,018 and 62 inches. So here you need to plan your route. So the question is, how many grams of silver chloride are produced from 4.3 grams of silver nitrate reacting with an excess barium chloride? So that just means that all 4.3 grams of the silver nitrate will react because the barium chloride is in excess. So we have enough to make sure that that reaction, all of it is reacted. So first thing is, how many railroad tracks do we need? So we will need 1, 2, 3, 4 railroad tracks, or 3 lines in it, because we're going to use our given, our 4.3 grams of silver chloride. So 4.3. And then we have to multiply it by its molar mass. So 1 mole over 168.89 grams of silver nitrate, because we need to get into moles. In order to go from moles to moles, or from one substance in a chemical equation to another substance in a chemical equation, you need to have it in moles. So we can't go directly from grams to grams. We have to go through moles. So once I've got that, I'm going to use the coefficients of the balanced chemical equation to cancel out my moles of silver nitrate to get my moles of silver chloride. And then I'm going to use the molar mass of silver chloride here in order to figure out the amount of grams that are produced from 4.3 grams of silver nitrate. So when you do the math, you get 3.61 grams silver chloride. So here's another question. How many moles of hydrogen are necessary to react completely with 50.0 grams of N2? So here's your balanced chemical equation. So where on the map are you first? So we are over here on the map. We're given the mass of substance 1, and we want to go to the mass of substance 2. But to do that, we then have to go through moles of substance 1, then use this mole-to-mole highway to get to your moles of substance 2, and then use that conversion there. So this is how I would set it up. I would have my 50 grams, my given of nitrogen, and then my grams of nitrogen from the molar mass. So molar mass. Okay. Then my grams cancel. I'm left with moles of N2. This moles of N2 can cancel, and this is from the coefficients. Balanced. And this last one is the molar mass of hydrogen. When I do all of that, my answer is 10.081 grams of H2. So you try one. How many grams of potassium chloride are produced if 2.5 grams of potassium chlorate decompose? So your answer would be 1.53 grams of potassium chloride.